So we got this spherical shell. Here it is. Underneath the pool of water. So the water is, it's underwater here. And the spherical shell is filled with alcohol. So this symbol here is density. So we have the density of the alcohol. The problem assumes we know the density of water. Density of water is 1,000 kilograms per cubic meter. So it's released from rest at the bottom of the pool, and they want us to find the acceleration of this sphere as it moves upward towards the surface. So this is a buoyancy problem. All right, so we got to start by doing a free body diagram. So what are the forces acting on this sphere? Well, we have mg down for the shell itself. Like just the material that makes up the shell has a mass of 0.4 kilograms. So this will be mass of the shell times gravity. And then what's the other downward force? What goes into the shell? Alcohol. The shell gets filled up with alcohol. So we have mg down for the alcohol. So that's going to be mass of alcohol times gravity. Now, there's an upward force. The upward force is the buoyant force. What does buoyant force always equal? The buoyant force is always equal to the weight of the displaced fluid, which is going to be mass times gravity for what? What's the displaced fluid here? Water. So this will be mass of water times gravity. Okay, so that's the free body diagram. Now we sum the forces. Summing the forces, we have, so we're going to say up is plus and down is minus. So we have mass of water times gravity minus mass of alcohol times gravity minus mass of the shell times gravity. Sum of the forces always equals ma. Now, what's this mass going to be? That mass is the mass of the shell plus the mass of the alcohol, right? It's the total mass of this whole thing, right? The shell plus the alcohol inside. So we're going to have to figure that out. Okay, fluids are tedious. You got to do a lot of solving for stuff. So let's clean this up a little bit. So for starters, we can factor out the g. Let's just do the algebra here. So acceleration, I'm going to factor the g out. G, mass of water minus mass of alcohol minus mass of the shell divided by m, which is going to be mass of shell plus mass of alcohol. Okay, so we got to figure out two things. We know the mass of the shell. The mass of the shell is 0.4. So we got to find out the mass of the water and the mass of the alcohol. So how do we find out the mass of the water and the mass of the alcohol? Well, for starters, we need the volume of the sphere. What's the equation for volume of a sphere? 4/3 pi r cubed. Just beware, this dimension right here is the diameter. So what's the radius going to be? The radius will be 0.1. So you plug this into the equation for volume. The volume of the sphere comes out to be 0.00419 cubic meters. Okay, so that's the volume. So now how do we get mass? Well, density equals mass over volume. So what's mass going to be equal to? Density times volume. So we do this for the water and for the alcohol. So for example, let's do alcohol. So mass of the alcohol is going to be density of the alcohol times volume of the alcohol. Okay, so the density of the alcohol is 806 kilograms per cubic meter, and then multiply that by our volume, 0.00419 cubic meters. Okay, so we end up getting mass of alcohol to be 3.376 kilograms, and then do the same thing for the water. Just change this from alcohol, just change those A's to W's, right? And by the way, the volume of the alcohol and the volume of the water are the same in this problem. Like the volume, where's the alcohol? Inside the sphere, right? But the water got displaced. So, the volume of the sphere is equal to the volume of the displaced water because the sphere is totally submerged. So the mass of the water comes out as, that's going to be 4.19. Okay, so now we plug in up here. So, need to make some room here. So we're looking for the acceleration. So you're going to go 9.8 meter per second squared. Mass of the water is 4.19 kilograms minus the mass of the alcohol, 3.376 kilograms, minus the mass of the shell, which is 0.4, and then divide this by the shell plus alcohol, which is 3.776, and we get an acceleration of 1.07, which is the answer.